well, wait a minute. It's from a vertex, how?
That goes straight down and it touches the center of
Center is a median.
not it just touches the middle.
That's a median.
Whatever.
Makes a right angle. It's perpendicular. All right. Which one of these letters is a vertex of the triangle? T or A? T. So I'm going to go from T perpendicular to the opposite side. You have to write the equation of a line. So if you recall, and this is one of the formulas that the EOC will give you. So here's your equation of a line. What do you need to write the equation of a line? You need two things. Slope. You definitely need slope and a point. Right? Isn't the y1, x1 a point? Which of these points is the point? T. And it's T because that's where it's starting. So you've got the point 1, 1. All right, next. Who is this? Okay. Next, you need slope. What is this relationship? Perpendicular. So you actually need a perpendicular slope. What do you know about perpendicular slopes? Opposite, reciprocal. All right. So you don't know this ordered pair, do you? No. You know R to be 8, 4. You know Y to be negative 3, 5. Can you find the slope of this line? Right here. Can you find that slope? Yes. Now, the slope of what we want is what kind of slope? Perpendicular. So you find the slope of RY, then you find the perpendicular slope, and with these two pieces of information, you come up here and substitute in. Yes, ma'am. Where did I get A4 in the beginning? I told you. Okay. Yeah. The beginning here is important for these. Yes. No. You have to find that slope, and you don't. If that slope is 4, what slope do you use?
Is it y2 minus y1 over x2?
Oh, that's what you're looking at. y2 minus y1, yes. Over x2 minus x1. All right, so that gets you started on your EOC. Shh. Where did I lose you? Pardon? I didn't ask you to do number 1. We were only doing number 2. All right, so if you're lost, you can listen to this tonight when you get home. All right, let's review where we began this unit. This is a review. This is going to my concept today. We've got triangle ABC is congruent to triangle FED. FED. All right. Given that, if you recall that if you have congruent triangle, then their corresponding parts must be what? Those corresponding parts are congruent. So there are 3 sets of congruent segments. There are 3 sets of congruent angles. Lizzie, name one set of congruent sides. AB is congruent to FE. There's one set. All right. Give me another set of congruent sides, Madison. AC is congruent to, okay, FD. Good. All right, there's only one more set of congruent sides, and that is going to go to Ethan. BC is congruent to okay, remember how we said B is in the middle, so we have to pick E in the middle, C is on the end, so we have to pick D on the end. Remember that? You got questions, test questions about this. All right, so now we got 3 pairs of corresponding angles. One pair is, Brittany? Angle. It's angle E and angle C and angle D. I need another pair of congruent angles, Tara. Angle A is congruent to angle F. And I need one more pair of congruent angles. That goes to Hale.
Angle B is congruent.
All right. Any questions there? Okay, it is this understanding that if, big if, you have congruent figures, then you will have congruent parts. You with me? All right. So this is what's going to happen today. The definition of congruent triangle states, and we are not going to use this abbreviation because I don't like it. Okay, so here we go. States that if two triangles are congruent, then corresponding parts of 4 congruent triangles are congruent. So this statement I've written out kind of abbreviated. Corresponding parts of congruent triangles are congruent. That's its abbreviation as far as we're concerned. So as we do the homework today, go over questions, I'm going to show you how this fits into what we've been doing. So this is what your homework should look like tonight. Your given looks similar, but look, how is your proof different? It's segments rather than triangles. However, hint, before you can prove segments or angles congruent, what must you do first? Prove the triangles are what? Are congruent. All right? You will not see this. Okay? That will not be written. You have to know that this comes first. We can only do this because the triangles were congruent. Are you with me? So this will be invisible. You have to know to do that. Invisible. So what I'm going to do is I'm going to ask what problem you would like me to do from the homework. Maria? 5. So I'm going to do 5. Oh, on your major terms, add this. This is the left column. Perpendicular lines. All right, if you're given perpendicular lines, what do we look for? We look for right angles. And what is the justification to state they're right angles? Definition of perpendicular lines. All right, do you have right angles anywhere on there? Do you have any? Yes. Do you have any is right angles on your major geometry terms?
Yeah.
Okay, what does the middle say? 90 degrees. What's the justification? Definition of right angles. So this is already on there. You don't have to put it again, but we need these. You have to add this to your study list. I gave you a lot yesterday on this spreadsheet. I asked you to highlight. And the key to being able to do these well is that you know all that I asked you to learn. You will not have this major term sheet when you take your test, nor will you have it for the EOC. That is why you will not have it for this test. Yes. And it will probably be drag and drop, where you have to drag in the reasons, drop the statements, that sort of thing.
Oh, is it on the computer?
It's all computer-based. And we are going to do a practice test. Hopefully, it's supposed to be kind of like the way you're going to see, because there's like 10 different types of questions on the 13th, I think, of February. All right. So with that said, I'm going to go ahead and we're going to go to number 5. All right, so I required that this was done on notebook paper last night. We've got W up here. We've got V over here. We have A there. And we've got T. Another requirement last night was that you wrote your given. And we are given that W or VW is congruent to TA. And you were given that WT is perpendicular to TA. And you were given that AV is perpendicular to VW. All right. And you are to prove that triangle WTA is congruent to triangle, that's triangle, AVW. Now, this is my pretend, okay? This is our new prove. Our new prove is WTTA, VW. Your new prove is to prove that angle TWA is congruent to angle VAW. So instead of seeing this prove tonight, you'll see the prove in green. So this is where I'm incorporating our lesson and going over the homework so we can do as much of the last night's homework as possible and bring in the lesson. All right. Yes, to do the green, you must do the pink, but they will not tell you the pink tonight. All right, so I need to know, Ethan, where do you want to begin with what we've been given? VW is congruent to TA, so we've marked those. All right, so what are we going to do next? How do I have nobody? Nate is not here. I thought he did too. Alexandra, you got a homework pass. Okay, what else are we going to mark in our picture? WT is what? What does that mean? What does perpendicular mean? Alexandra? Look at your major geometry terms. Find perpendicular. What do you know about perpendicular? Did you write this down today? Okay, what do you know about perpendicular? That forms. So we're going to put a box. What else are we going to do? There's two of them. And AV is perpendicular to VW. What else are we going to put there? Another 90 degree. All right. So far we've got that. All right. There's now. Nate. I wonder if that's supposed to be Trevor. Let's see. Is Trevor's name in here?
My name in there?
I just got picked twice.
Let's look. I thought I put Trevor's name in here. So we're going to take Nate out. All right, so there was I don't know how we got a blank in there. Madison King. Just kidding. All right, I don't know. Kind of weird.
Maybe my brother's homework class.
No, I don't think so. Okay, Mackenzie, you're next. Okay, so what else I guess what I wanted to emphasize is that we have already used this part of the given, all right? We marked it. We've used this because we marked a right angle, and we've used this. So as you can see, the given is gone. So that means, Mackenzie, that we're going to look at that picture, and there's two things we can pull from a picture. What are we going to mark on this one? WA. And what do we know about WA? What's that word? Starts with an R. Starts with an R. E. R-E. Yes. All right. So now we're going to look at this, and you are going to tell me What would the combination be to prove these two triangles congruent? Madison? Side, side, side. Is the angle between these two sides? Okay, angle, side, side. Now, what did we say that we do not have in geometry? Okay, no. So, with that, normally we would say we cannot use it, but what type of triangles do we have? We have right triangles. What is this? This is a hypotenuse, and that is a leg. So when you get this, check to see if you have right angles. If you do have right angles, then it is hypotenuse leg. Now, yesterday in your notes, very beginning of class, very beginning of those notes, if you have to use HL, what do you have to establish? You have to establish right triangles. TA is perpendicular. Now, notice in my given, I'm not going to put this in my given. I'm saving any congruence I'm saving for the alphabet justifications. All right, we are given this information. All right, so what do we know? Lizzie, what do we know? Before we can go to HL, yes, what do we know? What do you know? What does this tell you? Right, so what do we pull from that? Well, we can't jump that far. What kind of angles are they? Angle T and angle V are right angles. Now, what told us that?
Definition of right angles.
Okay, were we given right angles?
Definition of perpendicular.
There you go. All right, did you see that? Were we given the bisect piece or just the perpendicular piece? Definition of perpendicular lines. Tara.
When you have something, do you have to write out like angle T and angle V are right angles, or can you draw one of the many right angles?
You mean like a box? I would prefer to see RT. All right, so now, we did this. If you have right angles, what type of triangles do we have? Right triangles. So now we're going to say triangle WTA and triangle AVW are right triangles. All right, and how do we know that? No, hypotenuse leg is going to be triangle congruent to triangle. These is an and. How do we know these are right triangles? Definition of what? Right triangles. So this should have been the beginning of your notes yesterday that if we're going to use HL, this must be established. Now, I'm going to go ahead and I'm going to put my little H here and my little L here. Now we're going to go ahead and get these pieces justified. All right, so I need a hypotenuse. What would that be? My hypotenuse would be what, Miriam? WA is congruent to WA. Why? I asked Miriam.
Well, that was a general.
No, Miriam was for this. All right, so now we need the leg justified, and that's going to go to Brian. What's the leg? TA is congruent to TA. Does WV, is that the right order? You started with T? It's not V, because T is right, A is not, V is right, W is not. You with me? Okay, so you had the correct segment. We just got to get these vertices in the correct order. And why? How do we know that? It is given. I did not write it in the given at the top because I wanted to write it here so I knew we were justified. Do you see how this statement right here perfectly matches this statement right there? It is a congruent statement. That's the only time you can say given unless you write out what else it says. Now, with that said, after I get this, I've justified the hypotenuse, I've justified the leg. What's next, Aaron? What's my next step? Triangle. Okay, so if we did TWA, we went T, no mark, double mark. So we have to do V, no mark, double mark. So that means it's going to be what? V, A, W. And what's the reason? HL. Excellent. All right. So now we're going to go. Do you have a pencil or pen? All right. So now, this is our new step. This is our new step. All right. On your homework, you were finished. All right. This finishes your homework. But tonight, it will not. And remember, tonight, you will not see that. So what will my final step be? Aaron?
Oh my.
Aaron, what's my final step? Angle T WA is congruent to angle VAW. What's the reason, Aaron? We took notes on it just a few minutes ago. Did you write it down? What's it called? There you go. Corresponding parts of congruent triangles are what? Congruent. So, again, last night your homework stopped at step 6. Tonight you will proceed to step 7. But some of them are you fill in. It's from the book. No.
I have AP classes that are easier than this class.
All right. Next question. Next question? Yes, Stephanie. Which one? All right. So question 8 is telling us, I would say if there were any hard ones, this was the hardest one. Triangle ABC. Why do you have to what? Because you want credit for your homework. It's an isosceles triangle with vertex angle B. All right, that's important. Now I'm going to tell you that DB bisects angle ABC. And we're going to prove last night that triangle ABC was congruent to triangle CBD. But today, we're going to go a step further. And what are we going to prove? We are going to prove that AD is congruent to CD. Yes? Tonight, you have to do the green. The green sets up the other. Tara, if you don't, because that statement says corresponding part of congruent triangles, that means you better have stated them congruent. Okay? So we've got we've got A, B, C, D. All right. So actually, this was not what I thought it was. This should not be hard. Now, it does require you remember what a vertex, oh, wow.
Whoa.
It does require you to remember what a vertex angle is.
Right.
Yes.
Thank you, Rusher.
Um,
I have to go.
go. So we've got statements and we've got reasons. All right, so if your name's called, you know, it doesn't count while you're gone. Lucas, all right, what can you tell me? What can we mark?
You can mark AD with the hatch mark and then like CD.
Why do you want them to do AD and CD?
Oh, I thought that was good. ABC is isosceles.
With vertex angle B. What does that mean?
DB bisects ABC, so you would mark angle ABD.
All right.
Congruent to DB.
So Lucas correctly interpreted this bisect piece. Bisect means you should have two equal things. An angle's being cut in half, and he found two equal angles. Segments will never come from an angle bisector. All right. So that was good. So what else can we, so what we've done, Maria, we've used that up. What else do you want to do? He used that. What does that mean? What's an isosceles triangle? Oh, two equal sides should come from this. The question is, which two? AC?
All right.
I'm sorry, you what? Okay, so Maria told me isosceles triangle has two equal sides, so specifically if B is a vertex angle, what are my equal sides? Excuse me, I'm sorry, I'm listening. Yes? I need two sides. AD and CD is all one side. So vertex, this is a vertex angle. Which two sides are congruent because of that? AB and CB, exactly. All right. So now we've used up all our given. So now we go to the picture. Hale, what can we pull from the picture? What can we pick from the picture? What do you see in the picture that we can mark congruent?
A, B, and
We've got AB and CB already marked. BD with BD. All right. So with that said, what is the combination that proves these triangles congruent, Tara? Which what? Okay, so Tara, very intuitive here, she said we could have, bless you, we could have marked angle A congruent to angle C because if two sides of a triangle equal, angles opposite are equal. Yes. At which point, Tara, you would have had angle side angle. Okay? But in this case, what's marked is not angle side side. So we've got side, angle, side. Now, anything that was given that is not a congruence, like triangle A, BC is isosceles, and with vertex angle B, has to go here. We've got DB, that was not a congruence, bisects angle ABC, and that was all given. Okay, now we're going to start justifying our angles and our sides. So, what is the first set of sides you want to put in our proof? Lucas?
AB and BC.
Okay, he is going to say this is step 2. AB is congruent to CB. Why, Lucas?
Because the
What told us that?
isosceles
Definition of isosceles triangle. All right.
One more.
So now we need an angle. So where are my angles, Stephanie?
Stephanie.
Angle ABD is congruent to what, Stephanie? CBD for what reason? What told you that? Look at your given. Stephanie, why? Yes, because definition of what? Angle bisector. Okay? So now we need our third side. Where is our third side? Bryce? Bryce, where's our third side? We already did those two. We marked it. BD is congruent to BD for what reason? Starts with an R. All right. Now that we've justified all of those parts, what's the final statement on your homework, Elber? The statement would be triangle ABC is congruent to triangle CBD, and what's the reason? Okay, now that finishes the homework. However, okay, we have a new step tonight. So now this new step would look like what? Lizzie? Lizzie? Side AD to CD. Why? What's the new reason?
Corresponding parts of a
Congruent triangles are congruent. All right, I need your homework left on this back table as you exit. Pardon?
Can I take a picture of this last part?
Yeah. I could have done other parts that were. This is the orange is tonight's homework. No, you have to know to do the congruent triangle first. And one of the reasons why you know to do the congruent triangle first is because I don't do well with the mouse. To use this, what's assumed? Congruent triangles. So that's why. Who knows?